Part two. So I just proofread the last video. I cannot see, when I do this from my perspective, I can't see that yellow circle that you do. And when I just replay the whole thing, I realized that yellow circle darn near fits right in there, which I found that rather coincidental. So there's our owl from part one. So part two. Now we're talking about polygons, regular polygons. What do you know about a regular polygon? When I say that, two things should jump into your mind right away. I'll pause for a second. Oh, you know what they are. First of all, you know a regular polygon has congruent sides, and you know that a regular polygon also has congruent angles. Okay, we'll move that little dot out of there. Okay, now I got another question for you. So what does, let me see how this, so what do you think the center of a polygon? Why would the center of a regular polygon be important? The center. Well, the center of a polygon, of a regular polygon, is equidistant from all the vertices. It would look the same distance from all of the vertices. Move this red line out of the way. So there's my same, different polygon, but same concept. Sides are equal. We find a center. And from the center to the vertice, they are all the same difference. So as you can see in this pentagon right here, is that right? 1, 2, 3, 4, 5. There are 5 equilateral triangles. In this hexagon, there will be 6 equilateral triangles. So now what we need to know, once you know that, so far so good, now it comes the new term for the week. And that is, we need to know, and I'll tell you why in a second. Here's the dreaded red dotted line. It's always important. What do we call the height of all of these equilateral triangles? It's the distance from the center to a side. Shortest distance, right angle. What do we call this? This is a new term for today. What do we call that? You might want to take your notes on this one because this is the important part right here. And opossum. Oh, our second random thing for this slide, this video, opossum. Back to what I was talking about. The name of this is not, what is the name of the height of the triangle in a regular polygon? The name is, it's not opossum, it is apothum. An apothum. The name of the height from the center of a regular polygon to any side, there's center to any side, is called the apothum. So the apothum is the distance from the center of a regular polygon to a side. Okay? And it basically cuts those equilateral triangles in two. Why do we need to know this? Well, we need to know this because the area of a regular polygon, to figure out the area of any regular polygon, you need to know the apothum, which is this value, and you need to know what the perimeter of that polygon is, and you multiply it by 1/2. So that's your new formula. You want to write this down. The area of a regular polygon is 1/2 the apothum times the perimeter. Now this would be easy if, again, we gave you the apothum and I gave you this side. You could figure that out pretty darn easy, but you know it's not always that easy. You're going to get some values, and what don't we know? There's some stuff here that we do know that you may not have thought of. Do we know the angles of these triangles? And even though you haven't thought about it, you do. And you know them because the central angle of a regular polygon has a vertex at the center, and these central angle, this for the C, is the same angle all the way around. Since this example is a pentagon, to figure out the central angle, you simply take 360 and divide by the number of sides. So this angle right here would be 360 divided by 5 is 72. Okay, so it's going to be 70, the angle 72, that's 72, that's 72, that's 72, that's 72. They all equal 360. Okay, you need to know that now. When we get to this angle here, though, if the whole angle is 72, since this is perpendicular, it bisects an isosceles triangle, that's going to be 36. If this is a right angle, If that angle in this case is 36 degrees, we know what that one is there. So we can figure out for any regular polygon what all the angles of these triangles are. And so what we're going to go with then today, so here's an example. The next slide, next video, will be 2 examples. I'm going to go old school. I'm going to go full screen to use the little whiteboard back here for the next 2 examples. So here's a hexagon. And of course they gave you what you need to know. Hexagon, we broke out the apothem there, and there's this little right triangle. They gave you the 3. They gave you this apothem is 3 root 3. And you plug everything in. 1/2 times 3 root 3 times 36 is 54 root 3. Now notice what I've done here. I cannot do these problems unless I literally take one of these triangles and move it out of there and work with that. I love to work with just one triangle to make it a little bit neater. Here's my triangle from here. The A is the apothem. I make this part here is an equal part of the perimeter. You need to know both of these numbers to figure it out. And obviously, you're not going to get both numbers. You'll get one of them. You might get the apothem, but you won't have that. You might get the part of the perimeter. You won't have the apothem. You might get this one, the hypotenuse of that triangle, and not have either one. That's where those trigonometric ratios come into play that we spent so much time on the last few weeks. So next video, I'm going to give 2 examples of how to figure these out, and then you'll be ready to go. So part 3 is coming up. This was the opossums, not the apothem. The animal was the opossum. All right, part 3 coming up. Just go right down your module.